Good afternoon, everyone, and welcome to today's session, which is titled Introduction to Programmable Logic Controller. My name is David Popola, like you already know, and we've been having a lot of discussions already about this. So, I'll start with an introduction about myself. Many of you already know me, I would say maybe all of you. My name is David Popola. This is my LinkedIn profile. I just took a screenshot to share with you. So, like you see on the background, maybe many of you are already wondering what the name means. So, Oluwasegun is my first name, and you know me as David, right? So that's Oluwase and DA, which is David. And then I have a third name, which is Godwin. So that's where the name comes from, Oluwasedago. This is what my friends, my close friends, my classmates know me as. My profile says business management, project automation, programming, electrical engineering, technical lead. This encompasses all my brief career, 13 years now in engineering. Um, the last school that you see, which is displayed here, is the school where I had my master's degree here in Germany. So I had my bachelor's in Lautech, electronic electrical engineering. I graduated 2011, and after that, I've had the the opportunity to work in different organizations. Some of the organizations are listed here. Um, Adeco Project Engineering, where I had over 5 years experience, service engineering. I also worked at Caltex here in Germany. I've also worked at Tesla and General Electric, GE Vernova. So over the course of my career, I've had the opportunity to work in different industries, food and beverage, automobile, energy, building engineering. Okay, please, if you're joining the call, just kindly mute. Thank you very much. So we'll go right straight into the PLC. So PLC for short is named Programmable Logic Controller. And what is a PLC? This is a um, this is a definition I picked from inductive engineering, and I feel like it helps you to understand what we want to discuss about today. It says PLCs are industrial computers with various inputs and outputs used to control and monitor industrial equipment based on custom programming. So basically, when someone talks about PLCs, you should see them as a computer. Everyone on this call knows what a computer means. These computers, however, have inputs and outputs, which means it's able to collect some data into it, and it's also able to give data out of it. It stands as a processor in itself, interacting with inputs, processing these inputs based on custom programming, which means a PLC involves some form of programming. So many of us in this current world hear about programming a lot. I'm a programmer, I'm this, I'm that, I'm a software programmer, things like that. So PLC involves programming. We will talk about that in later discussions and classes. It says a PLC is used to control and monitor industrial equipment. So basically, a PLC is used in an industrial setting. There are different types of PLCs. There are different places where we can use PLCs. But specifically, the one we're talking about in this training has to do with PLCs used in the industrial environment. Now, I'll quickly give you a brief history about PLC. Before PLC was developed, there are things which we know as relay logic. So a relay is a device which is able to take some, with voltage applied through electromagnetic process, is able to give some contacts and outputs based on how we want it to operate. Many of you have just come back from CWES. I think all of you actually. Probably you've seen some control panels like this. If you're lucky, then probably you've seen the ones with PLCs already, which means the organizations have already switched from relays to PLC. So basically, before PLCs were designed, you had something like this in organizations. You see, each one that you see here is one of these, and each one controls a specific action. However, with the introduction of a PLC, everything that you see here can be done with this small device, which is a PLC. So here is a typical relay. Here is a contactor, which is also a relay. It's written on top of it, electronically mild relay, something like that. This is from Allen Bradley. You also had a standard contactor like this, which is also serving as a relay. You need to apply voltage to its coil and then it closes. And then with that closing, it's able to initiate what you want it to initiate. So in 1968, the first PLCs was developed, and this was done by General Motors engineers. The picture you see here is a picture taken with one of the first set of PLCs that was developed. So Modicon is the name. And when you go deeply into the PLC industry, you will hear a lot about Modicon. You can see that 1968, in terms of, I would say, technological breakthroughs, I wouldn't say this is so far ago. Although this is around more than 60 years now, I would say, yes. More than 60 years now, or less than 60 years now, that the first PLCs were developed. And why were they developed? Basically, PLCs are easy to program. Of course, you can see from this image, it's easy to work with this rather than with all of this. Again, you can change programs easily and you don't need to rewire the control system. They are smaller in size, which automatically makes it cheaper to install, to maintain, to replace, and they have a higher reliability. These types of relays are usually mechanically engaged. So if you're in a control room that has this old relay logics, this is a simple um, image here, and you apply voltage across its coil, you will hear the sound when it engages. You hear ta, ta. So imagine you have a process that is engaging many of these things. There's a lot of noise generated in the control rooms. And because they are also mechanically engaged, it breaks down easily and requires a lot of maintenance. So a PLC offers simple construction, low maintenance. It's also cost competitive, which means, for example, an organization can have a PLC controlling one of its processes and also are able to easily keep a spare of this PLC in the organization. It's easy. Rather than having a full set of control panel like this as a spare, that's not possible. So what people usually keep are the spares of these relays themselves. And when there is a breakdown, you have to switch, in most cases, switch off the whole system so that you can replace each of the relays. Now we'll briefly talk about a PLC architecture. So a PLC comes in different forms, in different physical forms. However, its internal architecture is the same. It's basically the same structure. Like we mentioned in the definition, there is the input side of a PLC, which you see here. There is the output part of the PLC, which you see here. There is the central processing module of the PLC. There is also a power supply to power the PLC itself. The power supply could be, in some cases, embedded with the PLC in itself, and in some other cases, a power supply can be a separate power supply with a cable connecting to the PLC directly. So, there are some images or icons that are shown here. These are some of the icons that control engineers, electrical engineers like you need to be familiar with. I hope somehow you understand this. I will also discuss them as we go on in the training. I will share some materials as we go on in the training. But these are icons or images or shapes that you would come across as an electrical engineer, as a control engineer in the field of electrical engineering. What you see here are switches. There are different type of switches. For example, this is a normally open switch. This is a closed, normally closed switch. These are different type of switches. Basically, there are input sensing devices that are connected to the input module of the PLC. And when the PLC processes whatever it wants to process, it's also giving an output to output load devices. In this case, could be a resistor, a motor, a light, an alarm, whatever. It could be any of this. Please, can you hear me clearly? Okay, thank you very much. So here, I'll give some deep explanation again. So for example, you have a PLC. This is a PLC in itself. And then you have a programming device. So a programming device could be anything, but in most cases is a PC, is a computer, a desktop, a laptop, whatever. It's a programming device. You use the programming device to connect and interact with the PLC because the PLC does not understand human language. We also do not understand computer language. So we need an interface which converts our own language to computer language and a computer language back to human language, which makes both of us understand each other. And this is what we use to program a PLC. So, functions of a PLC. There are different types of controls which you can use a PLC for. Basically, a PLC is used in organizations for control, for monitoring, for supervision, for different kind of things. Here we have sequence control. In this case, you have conventional relay logic control replacer. Like I showed earlier, that big panel that has a lot of relay, a PLC can do everything a relay logic can do. Also, a PLC can do functions like timers, like counters. So let me come back to lay terms now. So for example, you go into a room, right? You go into a room And in that room, you have a sensor which says if you are able to detect movement in this room, then switch on the light. A PLC does that. It means you have a sensor which senses movement. When it senses movement, it gives an output to a PLC. The PLC processes that input and then gives an output to the light. The light switches on. The same PLC can then be programmed to say, when you can no longer sense movement in this room, switch off the light. However, wait until 2 minutes to be sure that there is no one in the room. The PLC also can do that. So it has the ability to read inputs, to use timers, to do some counting, and gives outputs as well. Also, a PLC can replace a PCB, auto, semi-auto, manual control of machines and processes. A PLC can do a lot of activity, a lot in the industry. It also does advanced sophisticated controls. You can do arithmetic operations, information handling, analog controls based on temperature, pressure. When the temperature is 35, switch on the water. When the water is low, switch on the pump. When the tank is full, switch off the pump, things like that. It can also do PID controls. In fact, this is one of the main uses of the PLC in the industry. It also does a lot of motor control, like I just mentioned here. For example, for tanks, filling, for mixing of products. It also does supervisory control, process monitoring, like I just mentioned, which monitors detection of people in a space, um, giving alarms if there is a fire alarm. If you are able to detect smoke in this space, then raise an alarm, switch on the water. It's also able to do fault diagnostics and monitoring. A PLC interfaces with different devices, computers, whatever. It's able to do factory automation networking and so many things, so forth. Now, like I mentioned, there are different types of PLC constructions. There are different types. A PLC comes in different physical forms. You can already split the different physical forms into two or more, but here I'll talk about two, which might be interesting for you now. One of it is compact PLCs. So compact PLCs are PLCs which are integrated with input and output module. So the PLC itself is just one module. It has its input and output device together with it. Example is what you see right here. Another example is this. Another example is this. Another is this. And another is this. Many of you might be familiar with the Siemens logo. It's one of the most common. It's one of the most common PLCs out there. So with these PLCs, you can see directly that I don't know if you can read this clearly, but basically what you see here, this connection point is this one is 24 volt DC. That means you can power it directly from here. You can connect inputs, you can connect outputs. Same with this PLC, same with this, same with this. All the connection points are already embedded on the device. So it's modular. It's compact. Sorry, this is compact, not modular. Another type is the modular PLCs. The modular PLCs are expandable with modules. So there is the central processing unit of the PLC, and then you have input modules, output modules, communication modules, power module, whatever modules are attached to this type of PLCs. An example is what you see here. The main part here is the CPU, And then you have modules that you can connect and remove from the central module in itself. This is a Siemens version of a modular PLC. You can take out modules, you can insert modules, which means you can expand it as much as you want based on the limitation of the device itself. So it's not like you can put 100, 200, no. You can, of course, change the modules, but also subject to manufacturer specification. Another example here is the Mitsubishi PLC that you see here. So these are modular PLCs. And these two type of PLCs are what you will come across in different industries. You will come across the compact PLCs, which are used for maybe small machines, small devices, smaller systems. And then these modular PLCs are used for big processes, big machines that require a lot of input and output or a lot of processes. Here we'll talk about PLC components, and then maybe we'll see. The first part is this is not according to order, so I'll just go irrespective of the order. Power supply. A PLC can have AC or DC power supply. I've mentioned earlier, some PLCs have their power supplies embedded on them. You just need to go in with the cable, either AC or DC supply. And some PLCs have external um, power supplies. There is the I/O, so you will hear this term a lot, I/O, which is stands for input and output. So when you hear me say I/O or when you hear people say I/O, it's basically inputs and outputs. So a PLC has its power supply, it has an I/Os, which is either via AC voltage input and output, DC voltage input and output, analog input and output. Could also be special purpose modules. In some cases, high-speed timers, stepping motor controllers, PID motions. Basically, you interact with the PLC via its input and output module. Also, we have peripherals on PLC. So peripherals are devices that are, let me say, additions. They are add-ons. So for example, a PLC can have a network communication interface, which means apart from communicating with the PLC via input and output modules, you can also communicate with the PLC via its network communication interface. For example, if we're able to go into industrial communication, we will be using the network communication interface to interact with the PLCs. The HMI itself, which stands for Human Machine Interface, where whatever the processes the PLC is doing, you can already see on this interface, on the HMI. You have simulators, printers that you can connect with a standard PLC. We have the processor part of the PLC, which processes whatever is being programmed on the PLC, which could be arithmetic operations, logic operators, block memory moves, computer interface, local area networks, and different kind of functions. And then we have the memory part of PLCs. Um, the memory part of the PLC majorly are the ROM and RAM. For many of you that have a laptop or a PC, you should already be familiar with ROM and RAM, and I am very sure that now that you're in your final year, you've also heard about PROM, EEPROM, EEPROM, so many PROMs. But majorly, I highlighted these two, ROM and RAM. So the ROM is the read-only memory of major electronics. One of it is a PLC, where you only have access to read data from the device. Here we store specific manufacturer software, or I would say operating system of the PLC itself, just like your laptop, the operating system is usually on the ROM. And when you switch it on, this is the part that usually comes into play. This is the part that boots up your system. And then you have a RAM, random access memory, where you can write, you can read. This part contains the user program on the PLC itself. So basically, from this part of explaining the PLC components, you can see that it's quite similar to a standard computer in the industry. Right now, we've had 30 minutes of discussions. I'd like us to take a short break and then we can proceed. Is that fine? Or do we have any questions as at this moment? Okay, so thank you very much. We'll continue in the next 10-15 minutes.